Yeah, good morning. My name is Kristian Meier, and I'm with Sauce Labs. I want to thank Dimitri and EPOM and, of course, Technical Difficulties and for putting this all together. So round of applause for Dimitri. Thank you, sir. I currently live in San Francisco, and I've been in technology for 20 plus years. I'm a little jet lag, I apologize, so I'm going to go off of some of my notes, and I know my presentation is not as pretty as Dimitri's with all the great graphics. I've been working at Sauce Labs for the last 4 years. I've started with a sales engineering team, and now I'm part of the business development team. Over the past 20 years, I've seen the concept of DevOps and the practice change over time. So I'm really excited to be here at this kickoff and kick off the conference of all things DevOps and test automation. And I look forward to all of the events and hearing as many speakers that I can. Before we get started, does anyone here know this band, Sum 41? Yeah. So, yeah, great. Their first album was All Killer and No Filler. And so I'm hoping my presentation is all killer with a little bit of fluff. Why use the cloud in DevOps? So focusing developer resources on your core products and the create quality code faster. So the idea around the cloud is that you can scale. You can use it to run thousands of tests in parallel, which ultimately gives you speed. So the idea there is you run your entire test in parallel, which reduces your testing time down to under 4 or 5 minutes. Also reliable. Why focus your time, your developers' time, your guys' time on maintaining that cloud infrastructure when you can use the experts to actually run and maintain that infrastructure? This allows you to innovate faster, faster time to production, faster time to find bugs, and faster time to put out new features. A friend of mine told me code is like inventory. If it's not out in production and it sits on the shelf, then it's not doing you any good. And why we're here is ultimately to make more money. Why use the cloud in DevOps? Well, so an example here of Stubhub. Stubhub is an online ticket exchange company. The buyers where you can exchange tickets and sell events. It's a part of eBay. That was weird. And the way that did you guys see the mouse? The way that they used to do bugs was their finance company would say that they were supposed to maybe make $100,000 for this particular event or this particular concert sale. And the finance company would discover after doing auditing that they may have made 1/10 of that. So they would go back to the developers and say, why don't we have this much revenue coming in? And so the developers would go back and comb through the logs and look at the servers and realize that there was errors coming from particular OS and browser combinations, also coming from particular devices. They actually didn't test and they didn't know that they were having these errors, but they learned that through their finance company. So when they moved to the cloud and had the ability to test on multiple OS and browser combinations, multiple different devices, and before they pushed bugs into production, they were able to catch it. I put this up here as a reminder of the computer industry and kind of where I started. I started here with an Apple II Plus. I was 13 years old. I used it mainly to play games. And what was fun about it was you can actually, it taught me how to do innovation as well as figure out different ways to use the computer. So as a kid, what you could do is you could copy your friends' games using a copy program. But what was fun is you could take the disk, cut a notch in the side, flip it over, and then use the other side. So you could use a single density disk and make it a dual density disk by a nice little hack, a nice little trick. And I didn't know, but at the time I was learning to become a systems administrator and basically doing DevOps. This is how we did it when I started my career. I started my career at bigcharts.com. We basically had a centralized server where the developers pushed their code or copied their code on, And at the time, the names of the servers were always kind of strange. So the central server that we used was called Zeus. And as we know, Zeus is, the leader of all the gods from mythology. And I guess it makes sense that our source code repository was a server named Zeus. And as a systems administrator, we set up batch files and basically just X-copied over the code into production. And there was no sense of automated testing at the time. Basically, there was one guy named Russ that would just do manual changes. We did, however, have a type of a smoke test, which was called up.asp, which was an ASP page that went through and did a stock chart, pulled a quote, made sure that the site was working, and at the bottom it said up in green or failed, or you could see the error message. And we just set up, as a systems administrator, we set up monitors and all of these different iframes that just went through 500 different servers, and we could just quickly scan to see if it returned a quote and this server was up. And we also just basically had our users do testing. So keep in mind that this was a 750 million page view a month site, and rollbacks were pretty insane. If the servers were crashing and didn't work, we basically rebooted them, and if that didn't work, then we just rolled back using the same method. Okay, DevOps in the cloud have reinvented how we run our businesses. I know this is a cliche, but it's true. If you work at a bank, a finance company, a retailer, even ExxonMobil, the gas company, the fuel guys, have a mobile app that you can use to buy and pay for your gas. So what I think about this is everyone in the organization should practice DevOps, not just technical people. So the whole idea in order to should come down from the CEO down to the developers and back up. Oops. All right, so let's talk another example here of using DevOps in the clouds. Macy's, they're an American company. They're a medium-sized retailer. They do clothing, home goods, furnitures, mostly a brick and mortar company with 650 stores. They've been around since 1858. The fun fact about these guys is they weren't testing on Safari. They were just pushing code out to there because they didn't have the infrastructure. Once they started to test on Safari, they realized a net gain of more than $1 million US a month in revenue by moving to the cloud. And so, if you and I went to Macy's.com and tried to perform a checkout on Safari and it didn't work, we may switch to a different browser. But the majority of our customers will not do it. They will just say, nope, Macy's doesn't work. I can't buy this item. I'm going to go to one of the competitors, and I'll probably just buy it off of Amazon because I know that will work. All right, so let's define DevOps. And the reason why I like this is so we can define it so that we're all on the same page. And a lot of developers are really into philosophy. They study it, they preach it, you can tell it in the code that they write, you can tell it in the systems that they build. And let me talk about a little bit about what I believe is DevOps. And this quote here is from Adam Jacob, who's the CTO of Chef. Does anyone, we all know Chef, right? Yeah, great. So he did a talk a few years ago, and he was defining DevOps. And what I really liked about it is, how he talked about the style. But basically, it's a cultural and professional movement focused on how we build and operate high-velocity organizations born from the experiences of its practitioners, or us. And so let's just break that down a little bit. Cultural and professional. Cultural like music, art, or your heritage. Professional like a musician, a doctor, or a systems administrator. So the idea here is, does anybody know who this is? This is a band from the 80s called Gorky Park. I thought it was appropriate because we are here in Minsk, and Gorky Park's right over there. But so culture and professional, basically DevOps is both. It's focused on the way we build and operate. This is the details of how we build things like software and systems. We also care about how we build these systems and how we operate it over time. And the idea here is that DevOps is really focused on the details of how we operate over time for the systems that we build, and we actually care about these systems. Okay, high-velocity organizations. Our experiences with DevOps are unique to building high-velocity organizations. When the same principles are applied to low-velocity organizations, DevOps just simply doesn't work. So, an example of that was in my career is the only way to make more money back in the 90s, late 90s, was you had a job jump. So you had to transfer, go to another job. Well, working at Big Charts, I had some great experience with high-velocity organizations where we did revs of code daily. We pushed it out to 500 servers. Then I moved over to a large insurance company, and they completely didn't get the whole idea of being high velocity. They were still, developing on mainframes and green screens, and we would constantly just sit in meetings and argue and butt heads about the best way to deploy the code, how to run the code, what servers are we using, what systems we're using, and basically we had meetings about meetings and then post meetings about these meetings. And what I didn't realize at the time, but that they were a low velocity organization and they weren't really ready to move into DevOps or just any part of the future. Okay, so it's a cultural and professional movement focused on how we build, operate high-velocity organizations born from the experiences of its practitioners. So DevOps comes from doing it, practicing it, constantly improving your craft. So it comes from you guys, it comes from us. And again, it just definitely doesn't come from ING, which was that company I worked for back in the day. All right, we'll talk about a company here that they are a high-velocity organization. We all know American Express. It's been around since 1850. It's a credit card and financial company. They have 55,000 employees. And the idea of moving to the cloud, they saved over $2 million per quarter when they moved over to the infrastructure. So they were kind of struggling with how do they do it in-house? Do they buy the servers because they had all these legacy servers, and they were kind of the same boat as ING was, which they didn't want to. The guys that were running the servers and the systems didn't want to upgrade. They didn't know how to upgrade. They didn't understand the value. So when they moved over to the cloud, they realized a $2 million a month in savings and was able to pump out code faster. I mean, this is a huge company. They have developers geographically spread out all over the globe. They have development centers in Europe, India, and the US. And the only way for them to scale efficiently was to move to the cloud. All right, DevOps and the cloud. How do we do DevOps? So the first thing we need to do is choose the right languages and tools. So a fun part about our job is we get to learn all these tools and new languages. And new languages and tools are coming out every day. I know he's working on one. We got some guys here working on Cypress, IO. What is the best tool for the job? I like this slide because it's a little messy, and it's really here to emphasize that there are hundreds of different languages and frameworks that we can choose from, and basically choose the best one for your skill set. A lot of people are using open source technologies. There's a lot of people here that are involved in writing and maintaining those open source technologies. I mean, we have Git, Selenium, Appium, Water, Jenkins, JMeter, Chef, Docker, Nagios. I mean, the list goes on and on about all these different open source technologies that we have. I would recommend a framework and language that could scale easily. I was talking to some guys last night, and the reason why I put Nightwatch.js on this slide is because it was kind of the new hot language and framework a few years ago. And the problem is with Nightwatch, it didn't have the ability to scale. You couldn't run tests in parallel, and you couldn't run against multiple different OS and browser combinations. I remember sitting at a client's site called Airware, which they do the drones. They do it for surveying and taking pictures and whatever drone things can do these days. And we spent 2 months trying to get Nightwatch to run in parallel and run on cloud infrastructure. I had guys come in, from that, wrote Node and everything like that. We just couldn't get it to work. They finally settled on Java with TestNG, which was easy to scale. But I guess my whole point here is choose the right language and framework for what you want to accomplish down the road. Use continuous integration. I mean, it seems a no-brainer, but everyone's doing. Not everyone does it. I guess what does that mean? Always integrate your branches into master. They should be short-lived, iterative branches. Run tests on every code commit, and always fix the build when it goes red. Does everyone here fix the build when it goes red? Nice. I mean, I've been on several organizations, and I've seen a lot of testing dashboards that they haven't. These guys will just push code into production as red because it's always been there. It's always been that way, and they could blame it on the test, they could blame it on the infrastructure, they could blame it on old code that isn't there. But in order to scale and run DevOps in the cloud, we must fix it when it goes red. Write automated tests. Run these tests at scale. Run these tests against multiple OS and browsers. Use a combination of emulators, simulators, and real devices. Basically, use the cloud. So, I mean, it's very simple and an easy process to get set up. You may need to change and modify your code a little bit, but like I said, if you have the right framework and languages in place, you can easily scale and run on the code. All right, this is about as buzzwordy as I want to get. And you knew you had to see this architecture slide at least 1x during the show and presentation. So I'm assuming everybody knows shift left. And really the only way you can achieve that is if you run your tests and your infrastructure in the cloud. When you write unit tests, you can run them against a headless browser, but run them massively and run them every single time. Write integration tests, which will test multiple classes and units, and it'll make sense. Make sure that the test or the code you wrote work with the other pieces. Of course, functional tests, which are user-oriented, high-level, and full stack. It's your full regression test. And then finally, write smoke tests, which will quickly determine whether you broke the build or you broke the site, like we did back in the 90s with an up.asp page, and basically test it every step of the way. What we're seeing is, you guys know PayPal, right? It's an online PayPal system which was co-founded by Elon Musk. Musk and Minsk. But right now we are using, right now what they're doing is they're actually using the cloud and DevOps infrastructure to test their site every 15 minutes with Selenium tests. They're making sure that they can use, people can log in, people can send and receive money. And there's the new buzzword about that is called shifting right, which is meaning do your test in production. So here's a little bit piece of code, and it's really easy to scale. We all probably know this, remote WebDriver. You can hit URL endpoints like Sauce Labs to run your Selenium tests in the cloud and to scale. And you want to, of course, parallelize your tests. Here's a real easy way to do that. You can see I'm running 16 different OS and browser combinations. I have some emulators and some simulators down here. And you can see that I'm running these tests in Chrome, Firefox, IE, etc. You can also test parallelize at the test or method level. So in this instance, I have 3 tests times 16 different OS and browser combinations. Means I can run 48 tests in parallel which ideally gets me my testing time down to under 4 or 5 minutes. Here we want to collect some metrics. So collect operating system, network, data, application, performance, and your process. So what I think about metrics is I want to, look at 4 different pieces, basically keeping it simple. Have few systems as needed, don't overthink it, don't overcomplicate it. So to run in the cloud, we need, a source code repository like GitHub, a CI tool like Jenkins, some testing infrastructure like Sauce Labs, and some monitoring, maybe New Relic, Century IO, whatever. But basically, that's the pieces you need to run in the cloud. Here's some analytics. You can see in the last week, I ran 6,000 tests, and I got a 68% pass rate. Obviously, I needed to kind of practice what I preach and make sure that I can turn those reds into greens, but I can see that clearly by using monitoring and analytics. Here's an example of a network monitoring, and what I like about it is I can easily see that I have a 401 unauthorized error there, so I can click on it, find the link to the website or the API call that is failing, and easily and quickly fix that by using analytics or using from cloud services. Have a bug database. So you can triage and prioritize the bugs, use whatever method and software that you want, but be nice to your customers. The most successful customers are client-focused. And what I like about that last sentence is when I was a kid growing up, I worked in a restaurant. I was a dishwasher, I was a prep cook, I was a line cook, and we always struggled with the front of the house, which is the servers, and for whatever reason, the servers thought that the cooks were dumb, and we kind of thought that the servers were idiots, but we both wanted the same goal, which is ultimately to serve the customer the food they wanted on time, and it was good. Similarly, I'm finding here in software, in companies, is the back of the house, the developers and the engineers are in constant conflict with the front of the house, which is the sales team. The sales team thinks the engineers are nerds, and the engineers think the sales are dumb jocks. But the reality is we all want to do what's best for the customer. So the idea here is we should always keep in mind that the most successful companies figure out who their customers are and are focused on delivering products that they can use. Feature flags. Who here uses feature flags? Nice. I'm curious to learn more about feature flags, but for those who don't know what they are, basically a feature flag allows you to toggle on and off different features in your code base. So it allows developers to take full control of the feature life cycles without depending on code deployments. So for example, I can merge this into a master branch, toggle the feature off. I can turn it on without having to redeploy the code. So that means I can give different users different experiences and see how that functions and works. And I think like I said, I think you don't have to, it allows you to kill the features if it's not working well without having to redeploy your code. And this is kind of an example here of some code that shows the toggle on and off feature flag and the value of it. So there's some negatives to feature flags I'm discovering, stale flags in code, and you can imagine a product with 100 feature flags, and how do you manage that? So here, my question is, do we think we can scale with feature flags? If we add a little complexity to this application, testing becomes more complex. This doubles the feature code and the test paths, incrementing the paths that need to be verified, and more importantly, introduce a dependency on a specific version of the second feature that you can see here. So there's a lot of questions in my mind how we handle these complexities, and I'm looking forward to, hopefully somebody talks about it, but we could also just talk about it offline. And finally, I think this is like the biggest example of success when running into moving your DevOps operations into the cloud. So Walmart, as you know, is the world's largest retailer. They have over 11,000 stores, 55 countries, $50 billion in revenue with 2.2 million employees worldwide. They're competing against Amazon for business, and a few years ago their sales were dropping, their stock was dropping, and then in 2017 they came out with the strategy to compete with Amazon, and they built this tool called Test Armada. And this is a true example of, it basically encompasses all of the things that I was talking about this morning. There's continuous integration. There's a platform to do testing on. They collect metrics. We got stats from the front end, from the back end. They have a bug database as well as data insight. And the idea there is they are now running 50,000 tests a day on every pull request. Their entire test suite takes under 4 minutes against 700 unique OS and browser combinations and 300 real devices. And as a result of running DevOps and DevOps in the cloud, Walmart's e-commerce sale grew 44%, and they've actually been turning, a profit and making a ton of money off of their grocery store applications. So, and they're now competing with Amazon, all because I think a lot of it's due to their focus on DevOps and DevOps in the cloud. All right, that's it. Besides the technical difficulties, I was telling one of my friends, that I was doing this presentation, and she said, presentations are always hard, but if people learned one thing from the presentation, which I hope you did, then it was a success. So let's have a great conference. Looking forward to talking to a lot of you. Looking forward to attending these other speakers. And there's really a lot of talented people in the room. Thank you.
Guys, do you have any questions to Kristian? Есть ли вопросы к Кристину? Не стесняйтесь. Ну, хоть кто-то. Go ahead.
Hi, thanks for the presentation. I have a question. In your presentation, you stated that when you use DevOps in small companies, it's not gonna work. Is there any way to make it work, or any workaround? Or if you have a small company, you should just drop it?
No, it's not necessarily a small company that DevOps won't work in. It's companies that are not willing to move fast. So, for example, the insurance company that I worked at, they didn't want to move fast. Everybody there was complicit and compliant with, I'm gonna check in at 9. I'm gonna leave at 5. I'm just gonna make sure that my database works. I don't care. So small companies are often the people that want to use DevOps, especially in the cloud, because they don't want to buy the infrastructure on it. So it's not necessarily small companies. It's more of slow velocity organizations don't want to use DevOps because they don't want to create things faster. Does that make sense? Yeah, cool. Thank you.
Anyone else? Yeah. I'm coming.
Hi, Kristian. Thanks a lot for the presentation. So, you mentioned Walmart's grocery app. Could you please tell some more details how you dealt with it? Thanks.
Yeah, sure. No, good question. So the idea is now you can, and I don't know if you guys know Amazon bought, I don't know if you know Whole Foods, but Whole Foods is a grocery store chain, as well, and Amazon bought those guys to compete with Walmart's grocery store app. So the idea is I can go on this application, I can order my groceries, milk, meat, vegetables, whatever, and there's 3 parts to it. I can order it, it goes to a central place, where people go out and, pick up the groceries, and then they come in and they have an application that they can use, to bag all the groceries, and you can pull up to a Walmart store, grab your groceries and go, or they also have a delivery service that you can use for that. But the idea was, they really wanted to move fast, push code faster, and the only way they were able to do that is if they had all of these different OS and browser combinations, all of these phones at their ready. And like I said, they had a corporate mandate to run their entire test suite on every pull request in under 4 minutes, which to me, that's kind of really where these high velocity organizations need to be. Does that make sense? Thanks.